In this video we solve problem 2 of unit 12. In it we have two spheres separated a certain distance, 50 centimeters, and one has charge plus q and the other has charge minus q, in a way that the both conducting spheres have a difference of potential of V1 minus V2 equal to 100 volts. So we have a proton which charges the same as the electron, 1.6 times 10 to the minus 19 coulombs, and this proton is released from the surface of the first sphere and goes to the second one. And they're asking what is going to be the kinetic energy of the when it arrives to the second sphere. The easiest way to solve this problem is with the energetic constraint. If we neglect any friction, we're going to have that the total energy of the proton in point 1 is going to be equal to the total energy of the proton at point 2. The total energy of the proton at point 1 is going to be its kinetic energy, which is 0 because it was released from rest, time plus the electrostatic potential energy at point 1. And the total electric energy at point 2 is going to be the kinetic energy at point 2, which is what we were seeking to find, plus the electrostatic potential energy at point 2. So as the total energy of the electron doesn't change, this means that the kinetic energy at point 2 is going to be the electrostatic potential energy at point 1 minus the electrostatic potential energy at point 2, which is the charge of the proton times the potential the electric potential at point 1 minus the charge of the proton times the electric potential at point 2. This is the kinetic energy at point 2 is going to be the charge of the electron times the difference of electric potential. This is one electron, the charge of one electron times 100 volts, which is 1 electron volt. Which is 100 electron volts. You can also have this in joules, which is another measure of energy, because 1 electron volt is 1.6 times 10 to the minus 19 joules. So this is 1.6 times 10 to the minus 17 joules. To know the speed at which it collides with the sphere, with the second sphere, we just have to know that the kinetic energy is equal to 1 over 2 times the mass of the proton times the speed at point 2. So we can just say that the speed at point 2 is going to be the square root of 2 times the kinetic energy at point 2 divided by the mass of the proton. The mass of the proton is equal to 1.67 times 10 to the minus 27 kilograms. So with this and some calculations, you can prove that this second the velocity before it collides is going to be the square root of 2 times 1.6 times 10 to the minus 17 joules divided by 1.67 times 10 to the minus 27 kilograms, and this provides the solution that is V is going to be 1.38 times to the plus 5 meters per second.